Guns are used in 180,000 non-conflict homicides each year. More than half of these incidents go unsolved. In the US, for example, guns are responsible for 2/3 of all homicides. This amounts to 30 people killed each day, of which 18 remain unsolved. A further 220 people are injured. The average age of a victim is just 28. In total, gun violence costs the US economy $229 billion each year, even more than the cost of obesity. But what if there were a way to trace all gun crime? With Nucleotrace technology, we can identify a suspect from a victim's bullet entry wound alone, recover a history of ammunition previously used in the firearm, and trace 3D printed gun crime. And we can do all this within 1 to 2 hours of arriving at a crime scene. First, a unique identification number linking the gun owner, license number, place of purchase or ammunition barcode is encoded into fragments of DNA. DNA is an ideal molecular label because it is inexpensive, non-toxic and information-dense. The encoded DNA fragments are deposited onto the surface of ammunition cartridges in a post-manufacturing step. This can either be done at the factory or further downstream by hand. This gives each ammunition cartridge an identification fingerprint. The ammunition is marked so that an unbroken chain of identification is left on the hand of the shooter, gun, cases, bullet entry wound, and recovered bullet after firing. Any one of these 5 points is sufficient to identify a suspect. Samples are recovered and decoded at the crime scene in real time using new portable DNA sequencing technology and Nucleotrace software. Within 1 to 2 hours of arriving at the crime scene, a list of suspects is sent to law enforcement. With these massively expanded forensic capabilities, it is now also possible to trace international arms and ammunition transfers, monitor weapons stockpiles, address 3D printed gun crime, and identify wildlife trafficking networks.